Hey Algebra 1, this is Mr. Osborne. I am doing your Brave School review. Use this video as much as you'd like or as little as you'd like. It's just here to help you to get through your review and to help you review the problems if you don't understand how to do them. Okay? So if you have any more questions, again, you're going to come see me on Monday and Thursday afterwards anyway. So if you're having trouble with the problem, even after I explain it here, just put it like a star next to it. That way we know which ones to go over when you do come in. Okay? Let's get started. So the first one. First thing I notice is that between these two numbers I have signs. I have a plus and a negative. So that means I'm going to be either adding or subtracting. Not multiplying, adding or subtracting. Okay, so that's the first thing I need to recognize. The second thing is I have two signs that are right next to each other. Now we could do this problem without changing that. But I prefer to change it because it makes it easier to deal with. And we do something called leave, change, change. What that means is the first sign is going to stay the same, this very first one, whether it's positive or negative. And then the second and the third will change to their opposite sign. So what this looks like is this -7 will stay -7. That plus will become negative or minus. And then this negative sign will become positive. But because it's positive and it just makes the 8 positive, I'm not going to change it. I'm just going to leave it, or I'm not going to write positive is what I mean. Okay. Now we have a -7 minus 8. Now when I'm dealing with negatives, we like to use the box. I know your teacher may not have taught you this, but this might be something useful for you to help you with negatives, because I know sometimes they can be confusing when you're adding and subtracting. Now how this works is that when you have it simple, when you have as long as you take down these signs, you have to do leave, change, change first. What you're going to do is you're going to put all the numbers that are negative here and all the numbers that are positive here. So starting with the 7, it's negative, and also the 8 is also negative. So they actually go in the same box. If numbers end up in the same box, that means you would find the sum. If they're the same, you find the sum. Same sum. Okay? Sum means you're going to add them. 7 plus 8, 15. Okay? And now, to determine the sign of this number, it's whatever box the positive and negative is bigger. And there's nothing in the positive box, so naturally the negative is bigger. So this will be -15. Okay? And we'll use that box method a little later on. Another way you can look at this is if two signs are the same, for the two numbers, you're going to add them together. If the two signs are different, you're going to subtract, and we'll see that in a later problem. Now here we have 54 over 9, like a fraction. But remember, this line is also the same thing as division, taksim for you guys to speak Arabic. Okay, so 54 divided by 9 is 6. But then we have these negatives, so we have to figure out, is this negative or positive? Well, some of us already know if I divide a negative by a negative, it gives us a positive number. Okay, but here's a little tool you can use, the triangle. For adding and subtracting, you use the box. For multiplying and dividing, these two things, or darab and taksim, I use the triangle. So now, negative, what I do is, the first number here, this 54, is negative, so I take one out of my triangle. The second number, 9, is negative, so I take another one out of my triangle. And what I have left is a positive. So that means my number will be positive. Okay? Now this next one, again, this is subtraction because between 36 and 7, there's a minus sign. Some of us get confused and see these parentheses and go, oh, it's multiplication. But it's only multiplication if the number is touching the parentheses. So let's say I wrote it like this. That is 36 times -7. This is 36 minus -7. So you're not going to multiply it all here. Okay? But what I am going to do is I have these two signs in the middle. And if I have two signs that are touching in the middle, or they're right next to each other, I need to change them. This is a plus here. So we're going to leave, change, change. Okay? Leave the plus the same. That plus will become, that negative will become plus. And this negative will also become plus, but I don't have to write +7, so I'll just do 36 plus 7. And I don't need a box for that. It's just two positive numbers. That's easy. 36 plus 7, 43. Okay, point number 4. Now this is the case where you have a number that's touching the parentheses, like I explained in the last problem. If it's touching, this is multiplication. This is dot up. Okay, so now if I were to write it like this, 6 plus negative 10, this is 6 plus. Okay, you would add, or this is zad. Okay, now here there's no sign, so that means multiplication. So this is 6 times 10, which is 60. Okay, and now I've got a positive times a negative. So what I can do is take out my triangle. Now I already know in positive times a negative it is a negative still, but let me show you how to use the triangle. Positive 6, I take out the positive this time. Negative 10, I take out a negative. And then all I'm left with is a negative. So I know that 60 is negative. Okay? Next. Again, start with the numbers. Now first of all, this little symbol, it's not a decimal. It is also a multiplication, dot up. Okay? So this would be 4 times 12, which is 48. Or you could do the old-fashioned way, like you learned in elementary school. Put the bigger number on top, 4 times 2, 4 times 1. Okay? And then we use our triangle. Negative times negative, it leaves us a positive. Okay? Now decimals. First of all, recognize what's going on. There's a plus between our signs, and this 7.5 is not touching the parenthesis, so we know that it's not multiplication, but that it's addition. We're adding. Now here's the thing. You're adding 2 decimals. So whenever you set this up, you need to make sure that the decimals are lined up. Okay? Now before we do that, we have to do a little bit of thinking here. First, we notice that there are 2 signs right there in the middle, like before, that are touching or right next to each other. So I need to do change. Leave, change, change. 7.5, change this to minus, change this to plus, but again, we don't have to write plus if it's right next to the number. Now it's 7.5 and 9.2. So if I drew my box, that 7.5 would go here, and the 9.2 would go here, because the 9.2 is negative. Now remember, if they're in different boxes, you're going to find the difference, or subtract. And you always do the bigger number minus the smaller number. So what I'm going to do is I'm going to set up the bigger number minus the smaller number. But remember, in the end, when I'm done, I need to remember that 9.2 is bigger, so it's going to be negative. So I'm going to go ahead and write negative here. Okay? I'm going to subtract these, but I need to remember that it's going to be a negative number because in the beginning 9.2 was negative. Okay? So now we do 2 minus 5. Can't do that. 2 is not big enough, so we borrow from the left. This comes 12 minus 5, 7. And then bring down the decimal. That's why we line up the decimals. Okay? Let me do a little different color here. That's why we always line up the decimal. Okay? Okay, so now 8 minus 7 is 1. Okay? So there's our answer, negative 1.7. Okay? That problem takes a little bit of thinking. If you need more help with that one, come see me. Okay, now again, 7 minus 13. So this is a case where we have a positive and negative. The 7 is positive, 13 is negative. They're in our different boxes, so I will find the difference. Okay, so 13 minus 7, 6, and 13 is the bigger number, so it's negative. Okay, and again, I can say, oh, the signs are different. One is positive, the other is negative, so that means I always subtract. And then the bigger number wins, so I know it's negative. Okay, it's another way to see it. Okay, now this problem I have got 3 numbers, not just 2. But first, before I do anything, I want to change these signs because they're right next to each other. So these negatives will change. This stays the same, leave, change, change. So this will become, both will become positive. So let's rewrite it. Negative 18 plus 4 plus 5. Okay? Now what I'm going to do is I'm going to do this one step at a time. Now what I see right now is that the 4 and the 5 are positive. Okay, two positive numbers, you can just add them together. So right here, since they're both positive, I'm just going to add those two first. Okay, kind of look for the easy way out first. Okay, so that gives us 9, 4 plus 5. And now I've got a negative and a positive, and like I told you in the last problem, if they're different signs, you just subtract. 18 minus 9 is 9. And then which sign is it going to be? It's always the number that is bigger. So the negative 18 is bigger, so that means our 9 will be negative. Okay? Number 9. Here, division is what's going on between here, so taksim. So 36 divide 4, that's 9, goes into it 9 times. Okay, and now we want to use our triangle. The 36 is positive, the 4 is negative, so we know our 9 is negative. Okay, so that's what we have left. Okay, now number 10, fractions. Okay, in order to, first of all, let me just say this. Between the two fractions, we have a negative. So that means we're going to subtract. Okay, we're going to subtract, or nactus. Okay, now if we're going to subtract two negative numbers, what did I tell you before? Two negative numbers, that means they're in the same box, meaning you're going to add them. Okay, now here's the thing with fractions. When you add them, the denominators have to be the same. And once they are the same, you can add them. And in this case, they are. But you don't add the top and the bottom. You only add the top. Okay? Or subtract it, whatever is going on. You only combine the top two numbers. The two numbers on the bottom will stay the same. So our answer will still have 8 on the bottom. Okay? Now we saw that they're both negative, so that means I'm going to add the two top numbers. 1 plus 3 is 4. And they're in the negative box, so it's going to be negative. But then we have to realize that we can still simplify this number. Okay? And we can do that by recognizing that I can divide a number into both of these numbers. Well, first of all, they're even, so I know I can divide 2, but is there a bigger number you could divide into both of them to simplify it? And that's 4. So if I divide 4, top and bottom, 4 divided by 4 is 1, and let's bring the negative over, and then 8 divided by 4 is 2. And there's our answer, negative 1/2. You guys recognize that? That one was on your test. Okay, number 11. Now, okay, we've got a number that's in front of these parentheses. It's touching this parenthesis. So that means we're going to multiply. But what do we multiply is the question. Well, we multiply this 8 not only times the x, we also multiply it times the 4. This is called distribution. Distribute. Okay? One thing I like to use is a rectangle. And what I do is I put the number on the outside on the left, and the numbers on the inside I put on top. And just like a multiplication table, I do 8 times x, which is 8x, and 8 times 4, which is 32, and 32 is positive. So my answer, I don't leave it in the box, would be 8x plus 32. Okay? A big mistake I saw a lot of people make on the test is they forgot to multiply the second number. They would just write 4 here. Okay? You got to remember you're going to multiply this first number 8 times the second number as well. All right? Okay, so number 12, another distribution problem. So I'll set up my rectangle. I put negative 5, the number on the outside on the left, and I put the numbers on the inside on the top. Now remember, you want to include the negatives. If this is negative 5, put negative 5. This is also negative 6, so put negative 6. Okay, so now what I do here is I got a few pieces to this multiplication. I've got 5 and 3, so that's 15. And then times x, so x. But then it's also a positive times a negative, which gives us negative. Now this next one's going to be 5 times 6. And a negative times a negative gives us a positive. Okay, then when I write out my answer, I don't leave it in the box. Negative 15 plus 30, because it's positive. Okay. Number 13. Now this one, this is still another distribution problem. The only thing we don't see is a number in the front, but that number happens to be a 1. If you don't ever see a number, you can always be safe to say that there is a 1 there, and it happens to be -1. So we're going to multiply this -1 times the x and the -1 times the 42. And now some of you guys are used to just doing this, -1, you just distribute over like this and you don't have to do the rectangle, and that's fine. But you can also set this up with the rectangle as well. -1, the number on the outside goes here, -x up here, positive 42 here. And 1 times x is just x. Negative times a negative is a positive, so I'll just leave it like that. And then -1 times 1 times 42 doesn't change 42, but negative times a positive gives us a negative. So our answer will be x minus 42. Okay. Now this is where you're going to have to simplify again. All these problems are simplifying. Okay. In this case, we want to combine the terms that are like each other. Okay. In both this problem, number 15, this one, and also this one as well, which there's a similar problem on your review. Okay, so what we want to do, or what I like to do, is group together the terms that are similar, okay? Because we can only combine the ones that are similar. I cannot do 6x plus 2. Why? Because the 2 does not have an x like the 6. However, I can combine the 10 and the 6 because they both have x. And I can combine the 3 and the 2 because they are both just regular constant numbers with no variable. So the first thing I want to do before I start combining any terms is just like when we were adding and subtracting, I've got two signs here in the middle that are right next to each other or touching. So I want to simplify that by, again, using the leave, change idea. 10x isn't affected. This negative stays the same. And then this positive will become negative. This negative will become positive. But again, like I said before, if a number becomes positive, just write it that way. And you don't have to write plus here. Okay? Now, what I'm going to do is I'm going to group together the numbers that are similar or are like each other. So I do that by drawing shapes. I do a square around my first term. I just do whatever term is on the left. And I go across the problem and I go, okay, this 10 has an x. What other numbers have x? Well, this 6 does. Okay, so I'm going to draw a square around the 6x. But just remember, this is not just 6, this is negative 6x. So I want to include the negative. Okay, now nothing else has x, so I have to choose a new shape, and I'll start with the next term. And I'll make a circle around the -3. And the 3 is like the 2 because they both don't have variables. Okay? Now we can combine the ones that are the same. Okay, so first let's start with the 10x and the -6x. Now remember, this 10 is positive, this 6 is negative, so we'll do the box like I did before, and the 10x is positive, the 6x is negative, so I'll put that in the negative box. They are in different boxes, so I will find the difference, or subtract. The bigger number, now minus the small, 10 minus 6 is 4. And that's also a 4x. Okay? And the 10 is bigger, so we know it's positive. Alright, so now let's go to the other numbers. So now here, we have -3, so that goes here, and 2. Okay, so they are also in different boxes, so I'll also subtract 3 minus 2 is 1. And then the 3 is bigger, so we know it is going to be positive. So then our final answer after all that, I'll just write it in one color, just to keep it all uniform, is 4x plus 1. Okay? This is the same thing, I just wrote it again. Okay? Now let's go over to this problem. Now, as I start with this first term, I'm doing the same thing, combining terms. I'm going to put a square around it. However, just so I know what it actually is, remember, if there's no number in front of the variable or the letter, it's always a 1. Okay, wahid. And then I go across and look for a number that has y, like this one, and this -4y does. And then if you notice, we only have one number left. Okay, so that number will not be combined with anything. Okay, so now we have a -1 and a -4y. If I do my box, the -1 goes here, -1y, and this also goes here because they're both negative. That's right, sorry, we don't need the negative, so I'll just write 1y and 4y. Okay, both in the negative box. Now they're both negative, so we're going to add them. They're in the same box. We'll find the sum. So it's 1 plus 4. 1y plus 4y is 5y. And then we know it's negative because that's the larger one. And then we just bring down the other number because it didn't have anything to add or subtract to. And now we do -5 plus y. Plus -5y plus 11. Okay. Now here, we're going to do the same thing, combining like terms. But here, we want to start with leave change. Okay, so positive becomes negative, negative becomes positive, but we don't need to write that one. Okay, and then minus 5x. Okay, now I'll start with the 3x, put a square there, and now I'm looking for terms or variables or numbers that only have x. And some of you are saying, okay, this one does, right? It does have x. However, it's different because it has an exponent of 2. So that is not a similar or like term because it has an exponent of 2. So these two are actually different. So we wouldn't combine them. So I keep going. And then my last one is -5x. Okay? Color. So then I go to the next term, this -9x squared. Put a circle there. This 1 is obviously not. Doesn't have a variable at all. So that can't be combined. So this is also separate. Okay, so I can only combine two terms here. This 3x and the 5x. Now, question is, where do I start when I start writing my terms out? Okay. Now, if you notice, here I wrote 4x first. Okay. Here I wrote 5y first. The reason I did that is because to write the correct order, because in math it's like a language, you know. In English you start with a capital, you end with a period. And the same thing in math, you start with the number of the variable, you start with the term where the variable has the highest exponent. Okay? Not the biggest number or coefficient, but the highest exponent. So I'm actually going to start with this -9x squared. And again, the reason I did that is because out of all these numbers, it has the biggest exponent. There's actually an exponent on this 5x and this 3x, but it's only 1. And that's why we don't write it, because it's not needed. Okay? So I'm done with that one. Now the next one would be the x. Okay? And you always go in order from highest exponent to lowest. Okay? So now I've got this positive 3x, and I've got a -5. They're different signs, so I'm going to use my box, 3x, and then 5x is negative. And I know if they're in different boxes, then I'm going to subtract 5 minus 3x. The 5 is bigger, so I know it's negative. Done with that, and the last number I have is this 1. Okay? Okay, now, moving on to order of operations. Okay, a lot of you guys remember this. This is PEMDAS, going in the right order. Like I said before, math is like a language. You have to do things in the right order. Okay, so P, basically this PEMDAS abbreviation tells us the order we need to follow when going through problems like this, where we have both subtraction and multiplication, or division, addition, exponents, subtraction. It tells us what order do we need to go in. Okay, so it just depends. All right, so now parentheses is the P. This could also be brackets. Exponents is for E. So like this number, this 8 squared. And the M is multiplication. D is for division. A is for adding. And S is for subtraction. Okay. Now when you get to multiplication and division, you work from left to right. And also addition, we work from left to right. That keeps us safe. You don't always have to work from left to right, but it allows us to make less mistakes. Okay? So here, this first problem, going in order, do we have parentheses? Nope. Do we have exponents? Nope. Do we have multiplication? Yes. This little symbol means multiplication, so we do that first before we do anything with that subtraction. So we still write this minus, 16 minus, and then we do 4 times 3 first. Okay, so that's 12. Now, the last thing we have is minus. So 16 minus 12, 4. And there's our answer. That's it. Okay. Now this next one, a little bit more moving pieces here. Do we have parentheses? Nope. Or brackets. Do we have exponents? Yes. This one right here. Okay. So what you're going to do first is we're going to do 8 squared. Now remember, when you have an exponent, that just means you're going to multiply this number by itself this many times. So it's going to be 8 times 8. Remember our multiplication tables? It's 64. So we still write minus 64 plus 48 divide 24. Now some of you guys already know that you could do this at the same time, but let's follow the order just so we don't make any mistakes. Okay, so now we did exponents. Do we have multiplication? Nope. Do we have a division? Yes. Okay, so we'll do 48 divided by 24. And 48 divided by 24 is 2. Now, all we have left is subtraction and adding. So we work from left to right. Go from left to right. Okay, so what I'm going to do first, 77 minus 64. I could just do that over here on the side real quick, or you can do it in your hand, in your head, whatever you want. 7 minus 4 is 3. 7 minus 6 is 1. Okay, so that's 13. And then bring down the 2. And then 13 plus 2. 15. Okay. Okay. Let me zoom out a little bit so that we can see the PEMDAS over there. Okay, so now this one, first, do we have parentheses? Yes. Not only do we have parentheses, we also have brackets. These square things are called brackets. And we have brackets and parentheses. Okay. So what that means is first, we look at the brackets that are on the outside first. And we say, okay, we start here. Brackets on the outside. So that means we're going to focus in on the inside of these brackets. Okay, and typically brackets go on the outside and parentheses will stay on the inside if there are any. Okay, so we focus on this inside. Now within the brackets we have parentheses, so that means we're actually going to start right here, not with the exponent but here. Okay, so we're going to do 7 times 2. Rewrite everything here. Which is 14. 7 times 2. Now next thing we do, remember we're staying inside these brackets. Okay, we still have brackets or parentheses here, so we stay in here first before we move on to the outside here. Okay, so now next in order would be this exponent with inside the brackets. Okay, so 4 squared, or 4 times 4, is 16. And again, brackets are still there, so we need to add these two numbers first. Okay. So 16 plus 14 gives us 30. And at this point, we don't need to write the brackets anymore because we were just left with one number. Some of you are saying, oh, wait a minute, how can I do 28 divided by 30? How's that even possible? 30 is bigger than 28. Well, you have to remember that division can also be written in this form, 28 over 30. And it's like a fraction. Okay? And these two things, this division symbol and this line mean the same thing. So now what I can do is I can actually simplify this fraction. And I look for a number I can divide into both. And the most obvious right now is 2. So I divide 2. And 28 divided by 2 is going to give me 14. And 30 divided by 2 is 15. So my final answer would be 14 over 15. Okay, now substitute. Substitute the following values and simplify the expression. So what you do here is, if you see C, if you see whatever letter you see, you're going to substitute or plug in the number that it's equal to. So here, C is equal to 3, so I'm going to plug it in here. D is equal to -2, so I'll plug it in here. Now here's what I want you to do when you plug it in. Whenever you plug in a number, and this is for here on out for the rest of the year, if you plug in a number or you replace it with this letter or any letter, I want you to write parentheses, okay? And I'm going to show you why in the next problem, okay? And in the next problem after that, why it's so important. Okay, so I'm going to replace this C and D with a number. The C is going to be replaced with 3. The D is going to be replaced with -2. Okay, so here, again, like the previous problems, we have two signs that are touching, or right next to each other, so we'll change that. Positive becomes negative. That becomes positive, but I won't do anything with that. So 3 minus 2 is 1. Okay? So basically you're just plugging in the numbers and then evaluating or simplifying that expression. Now here, again, you have an A. Read these lines. So I'm going to plug in -8 here, and then 4 here. Okay? So remember what I said, if I'm going to plug in a number here, I'm going to write parentheses. And same thing here. So I plug in the -8 and plug in the 4. And this is why it's important, because we need to remember that to begin with, this was 3 times A. And now it's 3 times -8. And the reason I wrote the parentheses is to help remind us that we're multiplying here. Okay? And sometimes it's not always multiplying, like we're adding the 4, but here we're going to multiply the -8. Okay? So that's why we want to do parentheses, to be safe and make sure that we do that correctly. So 3 times 8 is 24. Positive times negative is negative. And then plus 4. And now we have two signs that are different. Like before, if the signs are different, they'll be in a different box. So we subtract 24 minus 4 is, it's 20. And the bigger number is 24, so we know it's negative. Okay? Okay, so now, for this one, B is -9. So every time I put in -9, I'm going to put parentheses. And again, this is important for this one as well. So minus, and it looks like I plug it in not once, not twice, not 3 times, but 4 times. Okay, so it's -9 minus parentheses minus, and actually let's write this out so that you can see what I'm doing actually. So it's going to be one number plugged in here, minus another number, minus another number, minus another number. And that number is going to be -9. So I put -9 here, -9 here, -9 here, -9 here. And now maybe you see why it's important to put parentheses, because we have two signs here, and that's going to change things. Okay? If you just plugged in the -9 without remembering that there's a negative here, you would have forgot that all these signs are going to become positive. Because leave, you're going to do leave, change, change a bunch of times. Okay? So these two become positive, these two become positive, and these two become positive. And it totally changes the problem. So that's why you got to be careful. So now it's just adding and subtracting, so work from left to right. So starting with the first two, -9 plus 9, well, they're different signs. So I subtract, and 9 minus 9 is 0. So this just kind of cancels out. Okay, and then I'm left with 9 plus 9, which is 18. Okay, and again, it's important here on this last one as well. I'm going to plug in a number for A, plug in a number for B, plus a number for D and a number for E. And you notice I put those parentheses touching each other, and before I even plug in anything, I know that I'm going to multiply two numbers here and multiply two numbers here. Okay, so A and B, -8 and -9. And then D and E was -2 and -4. I'm sorry, not -4, +4. So now, first, like PEMDAS, we do the multiplication first. So 8 times 9, that's 72. And then it's a negative times a negative, which gives us a positive. And then we have here 2 times 4, which is 8. And we know it's going to be negative. Okay? So really, it's this. Okay? But then I have 2 signs there. So that lead change, positive becomes negative, negative becomes positive, and 72 minus 8, that will give us 64. Okay? Now, here solving equations. I'm actually going to stop here and create a new video.